Welcome to December 20th LeetCode Challenge, power of 2. So given an integer n, return true if it is a power of 2, otherwise return false. An integer n is a power of 2 if there exists an integer x such that n equals 2 to the power of x. Alright, that's pretty much the explanation. So let's take some examples. Is n equal to 1 to the power of 2? The answer is yes, because 2 to the power of 0 equals 1. Is 16 to the power of 2? The answer is true because 2 to the power of 4 equals 16. However, 3 is not. So it's false here because there's no x value or exponent 2 to the power of n, 2 to the power of x, I should say. That's a whole integer that returns 3 as a result, right? There are constraints here. Can we do this without loops or recursion? The answer is yes. So I did the solution before, I just forgot that I wasn't recording the right screen. So let's go with an intuitive approach, right? So the intuitive approach I would come up and think about is, well, first of all, let's remove the base case, right? Anything negative or 0, or anything negative or 0 cannot exist because 2 to the power of 0 is, let's see. Yeah. See, so yeah, anything 2 to the power of anything negative won't work. So if n less than 1, we're going to return false. So this is our base case, just gonna remove that aspect. So intuitively, I would go with a loop. I'm using a divide and conquer technique. So the idea is that while the modulus of n to the power n mod 2, I should say, is not in that case, then we're going to divide n by 2. So how that works is not n modulus 2, and then we're going to reassign n divided by 2. So ideally, we keep on going through this while loop. If n is not 1, right? If n keep on equaling keep on equaling to 1, so that means the modulus is not equal to 0. That means it's going to keep on dividing n by 2 and keep on going, looping over and over until n equals a 1 or a 0, right? And that's when it exits the loop. So ideally, if it's equal to 0 when it exits the loop, that means n is not a power of 2. However, if n is equal to 1 and exit the loop, then that means 1 n is equal to is true. That means 2n is the power of 2. Run the code and check it out. Alright, submit it as well. Alright, accepted, awesome. So this is divide and conquer technique. So just divide n in the loop, in the while loop, until we get a 1. If the result is not 1, that means n is not a power of 2. Space complexity is big O to the power of big O log n. And that's time complexity, I should say. Space complexity is constant space. Alright. Can we do this without a loop? The answer is yes. It's a bit tricky, but I actually recently learned a lot of binary bitwise operations. And I think it's very applicable in this case. Because power of 2, if you think about it deeply, if anything to the power of 2, you could kind of, if you're familiar with binary code, that means that any single result of n is should be a binary expression of whatever's on the left hand side, right? So 1 in binary, right? So we have so anything to the power of 2 could be represented in a binary expression, or the binary form, I should say. So we know if we could represent n in a binary form, that means that the following is true. So the power, I'm going to write some pseudocode here. So the power of n, 2 to the power of n, so if that's equal to 1, which is bitwise masking with n, then we know that binary form this exists, right? We know this exists, it's given. We also know that for every binary form, for any binary expression of n, that this is also true. So we know that the power of 2 to the n, minus 1, it's like the binary form. So if we combine kind of these two ideas together, then we get something like this. So we get 2 to the n. We got to use a bitwise and here. Minus 1. So if this is equal to 0, then we get a, if that's equal to 0, that means that we are able to represent n as a binary form. That means that if n is a binary form, that means that n is a power of 2. Essentially, that's how it goes, right? If we could represent any number of n, given n, in a binary form, that means it is a representation of a power of 2 number. So more or less, that's the short form of it. So ideally, let's kind of write out the code. If we simplify this code a bit more, actually don't need to. So kind of simplify this out a little bit more. So instead of this, we're going to use n and n minus 1. So this means that we remove the last 1 from the binary expression of n. If and only if n is the power of 2, there will only be 1 in the binary form. So we kind of remove it from each side. So it's a bitwise and, right? And if you're familiar, this means that AND operation is it's a clearing type function in binary expression. So let's kind of write this out. So return n and not n, and we're gonna actually use this expression right here. So n bitwise and n minus 1. All right. Run this code here. Submit. Accepted. Awesome. So there you go. This is using a bitwise operation, the number of 1 bits. That's probably the next challenges here. This probably give you a hint here. But yeah, that's just without using a loop or recursion. All right, that's it. Have a great day, guys.